Hi, you guys. We've got conditional probability today. So remember, you already know what this bar means in probability with this symbol notation here, but conditional probability is the probability of an event knowing or given is our really important key word here. Another event happened. And so like a real life example that I like to think about, what is the probability that you go to Turnabout? But then what's the probability you go to Turnabout given all of your friends are going to Turnabout? So probabilities are probably different, right? If you know that all your friends are going, you're probably more likely to go. And so the given part is given that all of your friends are going. That's the known thing. That probably changes the chances of you deciding to go to Turnabout. So think about conditional probability in that term. In words, we read these symbols, probability of A bar B. What it means is probability of A given B. That bar means given. So we have a formula for it. It's probability of A given B equals probability of A and B. Remember that upside down N thing means and, divided by probability of B. I like to kind of look at this as a divisor, and so the divided by B is kind of the way that I remember the formula. So same thing over here, the A here goes in the denominator. So that's how you remember. And I also want to point out that this and this are the same thing. So B and A is the same as A and B. The order doesn't matter. So just know that that is the same thing. You can reverse those letters. Just a little tip for you. So let's just go right into a couple problems. We've got animal hoarders living next door to you, or next door to me, I guess. My neighbor has 3 black cats, 6 white cats, 1 brown cat, blah, 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 blah. Moral of the story here is that there are 30 animals total. Okay, so what I'm going to do here is find the probability of, let's see, that an animal escapes into my yard. Find the probability that it is a cat given it's a brown animal. So just using the formula and replacing the A's and B's from above with cat and brown, it's the same thing as probability of cat and brown divided by probability of brown. Okay, so we're going to do kind of 2 different things. Cat and brown means brown cats. That's what that means. So how many of the cats up there are brown is what you're looking at. So in this case, looking at all of the cats, it appears as though there are 1 brown cat out of 30. That's the probability that goes in the numerator. So cat and brown means brown cats. It's both a cat and it's brown cat. There's only 1 out of 30 there. And that's the numerator probability, but what is the denominator probability? What's the probability that the animal is brown? So that includes any animal that is brown. So looking up at the top, in terms of any animals that are brown, I have 1 brown cat, I have 8 brown dogs, and I have 2 brown ferrets. That's 11 brown animals altogether. And so when you flip and multiply those fractions, the 30s cancel and you get 1 over 11. And that's just practice using the formula. So let's try letter B also. Find the probability that it is a white animal given that it's a ferret. So probability of white and ferret divided by probability of ferret. Okay, so I'm looking up at the top and how many white ferrets are there? White ferrets, there happen to be 4 of them, so 4 out of the 30 total is the probability for the numerator. And then how many ferrets are there total? So we have 1 black, 4 white, 2 brown, that makes 7 out of 30. Again, the 30s cancel and we end up with 4 out of 7. Let's look at a couple more just for practice. Find the probability that it's not brown and a dog. So what that means is all the dogs that aren't brown, all the not brown dogs, so the white one, the black one, whatever, divided by probability of dog. So again, it's out of 30 total for each part of the numerator and the denominator. So how many dogs up there are not brown? So the total number of dogs I have are 2, 3, and 8. Which makes 13, but 8 of them are brown. So the not brown dogs are 5 out of 30. And then how many dogs are there total? 2 plus 3 is 5 plus 8 is 13. 30s cancel, and we get 5 out of 13. So very simple. So last one in this group is this one, probability that it is not a cat, meaning it's a dog or a ferret. Those are our only options, right? Yeah, so add up all the dogs and ferrets. And not white, divided by probability that it's not white. Okay, so we're looking at brown and black, it appears, and all the animals that are brown and black. Okay, so if you add those up, the probability that it's not a cat and it's not white, so throw out any animal that is a cat and any animal that is white, and you end up with 13 out of 30. And then the numerator, throw out all the animals that are white, and that's going to include all the animals that are not white. So get rid of all the white animals, and add those up, it gives you 17 out of 30. 30s cancel when you flip and multiply, and you get 13 out of 17. I'm going to skip number 2, and what I am going to do is go over to number 3. We're going to talk about tossing 3 coins, probability that at least 2 are tails given that the second coin is tails. So if you remember the heads and tails chart that we made when you toss 3 coins, I'm going to pause the video and draw that out to the side for just a second. So these are my 8 options in terms of heads and tails combos when you do 3 coins in a row. So remember, my first option is getting all 3 heads. I wrote that here. Then you could get the first 2 heads and then tails. That's here. Then you could get heads, tails, heads, and I'm just working my way to the right and listing all 8 of those combinations here. And so if we are given, and conditional probabilities restrict what you're looking at, so the given part is given that the second coin is tails, I'm going to highlight all of these that include the second coin being tails. So this one has a second coin of tails, this one has a second coin of tails, so does this one, so does this one. So now I'm only looking at those 4. And so after restricting to only these yellow ones that I've highlighted, my new denominator is 4 because there's only 4 options that have the second coin as tails. And how many of those have at least 2 tails? This is the question I have to answer. How many of them have at least 2 tails, which means 2 or 3 tails? And so this one has 2 tails, this one has 2 tails, and this one happens to have 3. So 3 out of 4 is my probability there. So I didn't have to use a formula. Sometimes the formula is a little bit more confusing. Same thing here, I'm going to use a different color, but given that the second coin is heads, that's restricting my table over here to only the second coin being heads. That's this one is the second coin being heads, this one, and this one. So now I'm doing red ones, and again, the option is over 4 because I only have 4 options here after taking into account the given conditional probability. How many of those 4 red ones have at least 2 tails? So only this one has 2 tails. The rest have a bunch of heads. So in this case, 1/4 is my probability. And that's a little bit of a shortcut. Instead of using the formula, you can look at a conditional probability as restricting your sample space. Remember, this thing here is referred to as the sample space because it includes all possible combinations of heads and tails for 3 tosses. Okay, I'm going to do 2 more examples. And so this is example 4 and 5. We'll talk about number 2 in class, the part that I skipped. But let's select one person from class at random. Probability that person can do a cartwheel, this sounds like an interesting experiment to do tomorrow, is 68% or 0.68. Probability handstand and cartwheel is 0.4. What's the probability he or she can do a handstand if we know they can do a cartwheel? So if we know part, this is the given condition. So given the person can do a cartwheel, find the probability that they can do a handstand. So it's probability that they can do a handstand given they can do a cartwheel. That's what the question is asking me here, and that is just what I took from this part here that they're asking. So I'm translating that into like the symbols that we know. Find the probability that they can do a handstand given they can do a cartwheel. So the given part is like the denominator part. So filling in this formula, what that means is probability of handstand and cartwheel divided by probability of cartwheel. And so now, since this is in kind of words, it's like a word problem almost, the probability he or she can do a cartwheel. So just a cartwheel is 0.68. That's what goes in the denominator, 0.68. And then in the wording of the question, I also have the probability that they can do both. The handstand and cartwheel is 0.4. That's what goes up here. Probability of handstand and cartwheel is 0.4. And just by using the formula, that gets you the answer of 0.59. Okay, we've got one more. The carnival is in town. My God, this is so much of a true story. If I ride a stupid tilt-a-whirl, I will throw up. If I ride it at least 5 times, there's a chance I'm going to throw up. The probability of me being peer pressured into riding it at least 5 times, dang it, I need to be stronger, is 0.32. What's the probability I ride the tilt-a-whirl at least 5 times and throws up? Okay, so here we have a given condition. If I ride the tilt-a-whirl 5 times, I am going to throw up. That probability, 0.84. That's our given condition. So if I tell you that I ride the tilt-a-whirl at least 5 times, I have a probability of throwing up. So probability of me throwing up, I'm just going to abbreviate throw, given I ride at least 5 times, trying to like use symbols here, is 0.84. That was given in the question. And so you have to kind of search through these word problems a little bit for the given part. It's given that if I ride at least 5 times, that's the given part, then the probability of me throwing up is 0.84. And I also have a formula that I could use. So probability of throwing up given ride 5 times or more is the same as the probability of throwing up and, I'm just going to say ride and not ride greater than or equal to 5, divided by probability of ride. So this is the formula, given the words of me throwing up, and I'm going to throw up. I have a probability of that if I ride at least 5 times or more. And the probability of me being peer pressured into riding at least 5 times is 0.32. So riding at least 5 times is 0.32. So I can fill in as many numbers as I can. I also know this conditional part. That number is 0.84. What I have to do is solve for this. The problem is asking me to solve for the probability of and, which is this part of the formula. So just plug in whatever numbers you know. Remember that the given part is the 0.84. So 0.84 equals probability of throw up and ride at least 5 times divided by, in the wording of the question we were given, the probability that I'm peer pressured into riding 5 times is 0.32. So plugging in everything you know, and now again, just by using the formula, you can multiply this over here and end up with the answer. And we get 0.2688 is the probability that I throw up and ride more than 5 times, at least 5 times, okay? So just know that formula for conditional stuff, you guys, and we're gonna do a little bit more practice with the formulas by going over number 2 in class tomorrow, and we'll do some more group work later on this week, okay? Thank you for watching. Have a great night.